Hello everyone, I'm Jivika Kancharla and today I'll be explaining you guys the solving of second question in homework 10 of the course Probability and Stochastic Processes. Before we look at the solution, let's have a quick look at the question. From my lecture notes, pages 1 to 50, collect the definitions of properties of different stochastic process. That is, white sense stationary process, independent increment process, Markov process, normal process, strict sense stationary process, white noise, mean ergodic process, and martingales. We are asked to explain our understanding about these properties. For example, the white noise is a process that its values at different times, that is x of ti and x of tj, are nearly independent. Actually, they are uncorrelated. So in that way, we are asked to explain all the 8 factors that are given in the question, the 8 points. Now let's look at one by one and see the definitions. Therefore, the first one is white sense stationary. A stochastic process is called white sense stationary when its mean is constant and the autocorrelation is a function of time difference. That is, white sense stationary only uses mean and autocorrelation to define if it is a white sense or no. They are much easier to get than a second order density. The autocorrelation function for T1 equals to T2, that is R of T1 comma T2, is the average power of signal at T1. We can see that the input is white sense stationary process. The output of state LTI system is also white sense stationary. In 2.2, we are asked to define about independent increment processes. It means that x of t1 minus x of t2 and x of t3 minus x of t4 are non-overlapping intervals are independent. Poisson process, random walk, and Wiener process are independent increment processes. Independent process is somehow related to Markov process. And in Markov process, x of t is a Markov process if the past has no difference in the future when the present is known. Poisson process, Poisson impulse, semi-random telegraph, random walk, and Wiener process have Markov property. The binary transmission in a secret time discrete state of Markov process are also a few examples. The Gaussian process, which is also called the normal process, is a process x of t can be said to be a random variable if x of t1, x of t2, and so on x of tn are jointly normal for any t1 goes t1 to tn, that is f of x1 to xn, comma t1 to tn is equal to 1 by 2 root 2 pi power n into det c into e power minus 1 by 2 into x underscore minus neta power t into c prime C inverse into x minus neta, where x is equal to is a matrix from x1 to xn, x prime is x of t1 to x of tn, neta is expected value of x, and c is equal to expected value of x minus neta into x prime underscore minus neta power t. The statistics of a normal process is determined by a term of neta of t and autocorrelation r of t1, t2. In general, neta is a function of t. Here, we are classifying Wiener process as a stochastic process and normal process and property of stochastic processes. What is a strict sense stationary process? A process is called as SSS, that is strict sense stationary, if its static is not affected by a shift of its axis time. The strict sense stationary process requires f of x of x1 to xn, t1 to tn is equal to f of x of x1 to xn, t plus e, t1 plus e, t2 plus e, and so on, tn plus e. This condition is very hard to meet, therefore it is very hard for a function or a process to be strict sense stationary. White noise. For a Wiener process, that is w of t, if we wish to discuss its derivative, that is vt is equal to dw of dt by dt, we have e of expected value of t is equal to dE into W of t by dt, that is equal to 0. Now Rv of t1 t2 is equal to alpha delta into t1 minus t2. A Wiener process does not have a derivative. We use Vt is equal to dW of t by dt just as a notation. Instead of Vt of dt, we can use dW of t. A Wiener process is continuous with probability 1. It has differential, that is dW of t, its Gaussian white noise with mean 0 and impulse of autocorrelation function. Coming to the mean ergodic process, Stochastic process xt is a mean ergodic process if limit t tends to infinity, 1 by 2t into integral minus t to t of xt of dt is equal to e expected value of t in a mean square sense. And last part is a martingale. A stochastic process x of t is martingale if e expected value of x of t and x of s is equal to x1, which is equal to x1. That is, the entire expected value is equal to x1 where s is less than or equal to t. This is true for random walk and Wiener process only. Therefore, this is the solving of second question in homework 10 of the course Probability and Stochastic Processes.